Hi, in this video I'm going to demonstrate to you how to set the angle of a servo motor to the neutral position using an Arduino circuit board. The neutral position of a servo is the point between the minimum position and the maximum position of the servo driving range, which is typically a range of 180 degrees or thereabouts. In such a case, the neutral position would be the midpoint from which the servo could, in theory, drive counterclockwise by 90 degrees or drive 90 degrees clockwise. In reality, a servo in a non-modified state might not be able to provide a complete range without putting mechanical stress on the servo. When using the Arduino to command the servo to rotate to a particular position, the value 0 is the minimum position, not the neutral position, and 180 is the maximum position. Since the neutral position is defined as the midpoint between the minimum position and the maximum position, this means that the value 90 brings the servo to its neutral position. What is actually happening is that the Arduino is sending a 1.5 millisecond pulse signal to the servo, which is the signal it needs to move to the neutral position. However, I want to modify my servos so that they can rotate continuously in order to gain speed control of my servos, though I will lose positional control. But before I modify my servos, we will need to command each servo to rotate to the neutral position. In other words, we will need to send the value 90 to the servo. The same method that I use can of course be also used to rotate your servos to any other specific position. I will be using very inexpensive servo motors, standard high-tech HS311, a few wires, an Arduino circuit board, and a battery holder with 4 1.2 volt rechargeable batteries installed. This gives you a 4.8 volt power supply. My battery also has a built-in off and on switch. Next you will need the Arduino IDE. IDE just stands for Integrated Development Environment and is basically just software that you need in order to create, compile and export programs to your Arduino board. Just go to their website and download an Arduino IDE. The latest version at the time of making this video is 2.0.4. You have download options for Windows, Linux and Mac. I will be using Windows 10 for this video. If you're feeling generous, you can donate some money when you download, or you can download without contributing. Getting back to our little project, this wiring diagram would normally be the way to connect the components up. However, since this is just a test, I don't want to solder any wires together like for the ground wires indicated in black here. Hence, I have decided to utilize a breadboard like this, simply just to connect the ground wires together quickly. Let's start by connecting everything up. The servo has a black ground wire connected to the breadboard, a red positive wire coming from the battery pack to the servo, and a yellow control wire, which is the wire we use to control the angle of the servo. I will connect the yellow control wire to the analog right pin number 9 of the Arduino. It is possible to connect the positive red wire of the servo directly to the Arduino and not use a separate power supply for the servo at all. It would work, but it is not recommended practice, as the current load drawn from the servo may potentially cause the Arduino to reset. A separate power source like this is recommended, or like this with a breadboard or any other type of circuit board. So after connecting all the components according to the schematic diagram that uses a breadboard, you get a setup like this. As you can see, the yellow control wire is plugged into the analog right number 9 pin on the Arduino, and the black wires from the servo and the battery holder are each connected to the ground on the breadboard, and a black wire also connects the ground from the breadboard to ground on the Arduino. Although it's hard to see here, I made sure the switch on the battery holder was off. Time to plug the Arduino into my laptop. So here I've opened up the Arduino IDE and written up a very simple program. I'll just briefly run through the code here so we're all on the same page. Here I have included the servo library. I've declared just 3 different variables: POS for the angular position of the servo in degrees, servo pin, which I've set to 9. This will be used to analog write to the analog 9 pin, to which the yellow control wire from the servo connects, and servo delay, which I have set to 5000 milliseconds or 5 seconds. I've set it to that for illustration purposes, which you will see soon. Here I have declared a servo object, my test subject. In the void setup I put in serial begin 9600 for the serial monitor, and my test subject dot attach servo pin, which tells the Arduino that the servo object, my test subject, is connected to the port that is determined by servo pin, which is pin 9 on the Arduino. Then into the void loop, I have just simply put in 4 lines of code and duplicated it a few times. You could ask the user for input instead, but for simplicity I just set the variable POS to 0 here, the minimum position, 90, which is the neutral position, 180, and back to 90. I used my test subject, which is the name of my servo object, .write POS, so that the value of POS is written to the servo object my test subject, which in turn is attached to servo pin, which has been declared here as servo pin equals 9 on the Arduino circuit board. For my intended purpose, I only need these 4 lines of code in the void loop, as my main purpose here is just to simply set the servo to position 90, the neutral position. However, I thought I would also demonstrate the servo moving to the minimum and maximum positions as well. So here we go, press the arrow to compile and run. We need to turn the switch on at the battery holder as well. So the servo has moved to position 0 and it will hold there for 5 seconds. Now it has moved to position 90, the neutral position. 5 seconds later the horn has moved to 180 degrees, the maximum position. Now it has moved back to the 90 position. And that's where I'll stop, by turning off the switch at the battery holder. So there we have our servo at the neutral position, ready for the next procedure. And that is to modify my servo so that it can rotate continuously in order to attain speed control. To see how I modify the servo, click here. To see some other videos on my channel that I recommend, click here. Thank you for watching.